Hello and welcome to this tutorial for using AMD Vitis subsystems for AI engine and programmable logic co-simulation with the AMD Vivado XSim simulator. We will begin by briefly explaining what a Vitis subsystem, VSS, is and how it can improve your design flow. We will then demonstrate step by step how to use the VSS flow to simulate AI engine and programmable logic PL components in tandem. The AMD Vitis subsystem is simply a self-contained package of interconnected AI engine and PL components. This package is platform independent and reusable, allowing it to be linked to any hardware platform that targets the same part. It can contain HLS and RTLPL components in the form of .xo files and packaged IP repositories. AI engine components are similarly linked using libadf.a files. There is also support for adding metadata, simulation models, and other generated design sources. Example VSS components can be found in the L2 directory of the Vitis DSP library. AMD Vitis Model Composer version 2025.1 also added support for exporting AI engine and PL functions as a VSS component. The utility of a subsystem consisting of AI engine and PL components rather than only AI engine components may not be clear at first. This diagram of a polyphase channelizer offers an explanation. Some functions are best implemented in the PL, whereas others are a better fit for AI engine tiles. Having an ensemble of PL and AI engine functions results in a more efficient design in this case. Furthermore, the AMD Vitis subsystem allows the entire polyphase channelizer to be modeled and tested as a single entity, instead of being limited to only testing these functions in their individual domains. The VSS flow simplifies development, testing, and delivery of heterogeneous designs. A top-level HDL test bench can be used for simulation without a platform or SIPs. This allows for more flexible development and testing of interconnected graphs and kernels. Migrating functions from the PL region to AI engine tiles is also faster since existing RTL verification environments can now be reused. Faster migration allows for deeper exploration of AI engine tiles for functions, potentially resulting in more efficient designs. Support for VSS hierarchy also allows for intuitive, RTL-like modular design. The resulting VSS component can be deployed like traditional IPs. Let's move on to a demonstration of AI engine and PL co-simulation using VSS. This video will be centered around the XSim simulator, but third-party simulators will be supported in future releases of the AMD Vivado design suite. The example files used during this demo can be found in the Versal Vitis subsystem flow design tutorial in the Vitis Tutorials GitHub repo. Begin by ensuring that all required AI engine, HLS, and RTL kernels have been compiled and verified in their own domains. Refer to UG 1701 for specific details on compiling kernels. AMD Vitis subsystems are configured using a config file. Specify the clock frequency for every PL component using the Frec Hertz parameter. Set the VSS parameter according to the specific PL kernels and AI engine graphs to be included. Make interface connections just as you would when generating an extensible platform. Use the v++ link command with arguments for setting mode to VSS, part name, VSS config path, list of kernels, and path to destination build folder. With the Vitis subsystem configured, generate CRTS for the target simulator. CRTS makefiles are created during AI engine compilation and can be found in the system C directory inside the AI engine work folder. I will use the make command on the .xsim makefile. Set these environment variables to allow XSim to connect to AI Engine Sim. AIE work directory points to the work directory paths for for each AI engine kernel. The AI eSIM options variable points to the AI eSIM config file's path. For this demo, the config file is simply a text file with AIE dump VCD set to enable VCD dump from the AI engine SIM. Create a Vivado Design Suite project targeting the same part as the generated VSS. In the Tcl console, use the vitis import VSS command with the path to the VSS. This will import the VSS into the Vivado tool as a block design file. In the Sources tab, right-click on the VSS block design and generate an RTL wrapper. Use this RTL wrapper to instantiate the VSS as the DUT of a top-level HDL test bench. Add test bench driver and monitor modules as needed to verify the VSS simulation option. Import the test bench, driver, and monitor source files into the Vivado Design Suite. Click Run Simulation in the Flow Navigator and the Run Behavioral Simulation option. Note that the example test bench designates the output signals of the AI engine graph with the AI engine 0 prefix. Run the simulation for 5 microseconds. The simulation results for the VSS are now visible. Thank you for watching.